Welcome to Shri Learning Academy. Let's simplify zombie and orphan processes. When we talk about processes in an operating system, we already know from earlier lessons that a process is simply a program in execution. It is not just the code stored on disk, but the live running version of that code, along with its memory, CPU state, open files, and other resources. We have also discussed how processes are created using system calls like fork and exec, and how they eventually terminate using exit. Now, in this part, we focus on two special situations that can happen during process termination and parent child relationships. These are called zombie processes and orphan processes. The names sound dramatic, but the ideas behind them are actually quite logical once you see how they fit into the process lifecycle. Let us start by setting a small background so the idea flows smoothly. In most modern operating systems, especially Unix and Linux based systems, processes are created in a parent child relationship. When a process creates another process, the creator becomes the parent and the new process becomes the child. This relationship is important because the operating system uses it to manage resources, track execution, and clean things up properly when processes finish. Now imagine a parent process that creates a child process to do some work. For example, think of a shell program, like the terminal you open. When you type a command and press enter, the shell creates a child process to execute that command. The child process runs, completes its task, and then terminates. At this point, the operating system needs to collect some information about how that child process ended. Did it finish successfully? Did it fail? How much CPU time did it use? This information is useful to the parent process. This is where the wait system call comes into play, which we briefly touched earlier. The parent process is expected to call wait or a similar call to collect the termination status of its child. When the parent does this, the operating system can safely remove all traces of the child process from its internal tables. Everything is cleaned up properly and life goes on normally. But what happens if the child process finishes execution and the parent does not call wait? This is where a zombie process appears. A zombie process is a process that has finished executing but still has an entry in the process table. It is not running. It is not using CPU time. It is not holding memory or files. But it still exists as a record because the parent has not yet collected its exit status. You can think of it as a process that is technically dead, but whose death has not yet been acknowledged by the parent. An example can make this clearer. Imagine a parent process starts a child process to calculate something simple. The child finishes very quickly and exits. However, the parent is busy doing other work and never calls wait. The operating system cannot completely remove the child process entry because the parent might later ask for its status. So the OS keeps a minimal record of that child. This record includes things like the process ID and exit code. This state is what we call a zombie. That is why the name zombie is used. The process is not alive in the usual sense, but it is not fully gone either. It is just lingering in the system as a small record. Now, an important point to understand is that zombie processes are not directly harmful in small numbers. Since they do not consume CPU or memory, they do not slow down the system immediately. However, the process table has a limited size. If a program keeps creating child processes and never waits for them, the system can eventually run out of process table entries. At that point, no new processes can be created, and this can cause serious problems. This is why good programming practice requires parent processes to properly handle their children and call wait when needed. In long running server programs, for example, failing to reap child processes can slowly fill the process table with zombies. Now let us shift our focus to orphan processes, which are related but conceptually different. An orphan process is a child process whose parent process has terminated before the child finishes execution. In simple terms, the parent dies first, leaving the child behind. At first glance, this might sound dangerous. What happens to the child? Does it become uncontrolled? Does it crash the system? Fortunately, operating systems are designed to handle this situation gracefully. When a parent process terminates, any child processes that are still running become orphan processes. But the operating system does not leave them without supervision. Instead, it assigns them a new parent. In Unix and Linux systems, this new parent is usually a special system process called init, or in modern systems, systemd. This process has a very important job. It acts as a caretaker for orphan processes. Let us look at a simple example. Suppose you start a program from the terminal that runs for a long time, like a background task. Then you close the terminal window or the shell crashes. The shell process, which was a parent, is now gone. But the child process is still running. Instead of being killed automatically, the operating system reassigns that child to init or systemd. From that moment on, the system process becomes its new parent. Why is this reassignment important? Because when the orphan process eventually finishes execution, someone still needs to collect its exit status. The init process always calls wait for its children. This ensures that orphan processes do not turn into zombie processes permanently. In other words, orphan processes are rescued by the operating system and cleaned up properly when they end. This highlights a key difference between zombies and orphans. A zombie process has already finished execution but is waiting for its parent to acknowledge it. An orphan process is still running, but its original parent has disappeared. In most systems, orphans do not remain a problem for long because they are adopted by a system process that takes responsibility for them. Another way to understand this is through a real life analogy. Imagine a factory where a manager assigns a worker a task. If the worker finishes the task but the manager never checks the report, the completed report just sits there on the desk. That is like a zombie process. Now imagine the manager leaves the company while the worker is still doing the task. The company assigns a new manager to oversee that worker. That is like an orphan process being adopted by init. It is also important to understand that zombie processes are a normal part of process management for a very brief time. There is always a small window between when a child exits and when the parent calls wait. During that time, the process is technically a zombie. This is expected behavior. Problems arise only when zombies accumulate and are never cleaned up. Orphan processes, on the other hand, are not considered harmful at all in normal operation. The operating system expects parents to terminate sometimes, and it has a built-in mechanism to handle the children they leave behind. From an exam or interview perspective, students often confuse zombies and orphans because both involve parent-child relationships and termination. The key is to remember the sequence of events. In zombies, the child dies first and the parent is still alive but careless. In orphans, the parent dies first and the child is still alive and running. As you move forward, especially when you study scheduling and process termination in more depth, these ideas will connect naturally. Understanding zombie and orphan processes gives you a deeper insight into how carefully an operating system manages even edge cases. It shows that process management is not just about running programs, but also about cleaning up after them in a controlled and predictable way. That is it for this video. See you in the next one.